Mr. Harmless here, and we're doing some practice with 45, 45, 90 triangles. And I'm going to solve each one of these, and I put down here at the bottom for those formula lovers formulas that you could use. I usually don't focus on this, but I'll talk about how to solve these. But if you like a formula, I'll probably try to mention this as well because I know some of you just love the little formulas. So we'll come at these from both perspectives. Okay. I'm also going to help you think through how do you do one of these problems, right? When you're doing these problems, what are you doing? And so there's going to be some steps, and let me move this first one down just a little bit. There's going to be some things that I do each time. So I probably won't mention this every time, but if you pay attention to what I'm doing when I'm solving these, there's certain things I do. So you're gonna hear me first. The first thing I do is I'm going to identify the triangle, right? Identify because not always is it going to be a 45, 45, 90. And so I identify the triangle first. The second thing that you're going to hear me do is I'm going to identify the parts, right? Okay, is it a leg? Is it a hypotenuse? What are all those parts? You're going to hear me do that. After I identify the parts, I'm going to figure out what I'm going to do with the numbers. So do, and it's either going to be multiply or divide. And then I'm also going to figure out by what number. That's a hashtag for some of you, but that's for us older people. That's the symbol for number. Okay, so figure out what number, and then we're going to work it out. And work, and that includes simplifying anything that needs simplified. So as I'm doing these, you'll hear me do these steps. Okay. So this first one, I'm going to really try to focus on it, but then as we go, you're going to hear me do those steps. So let's start with this first one. So I'm looking at this triangle. If I get to this first question here and I go, oh man, what is this? I go, oh, 45, there's a 90. Well, they have to add up to 180. So I know this is also 45. So I just identified that this is a 45, 45, 90 triangle. Then I go, okay, well, let's see here. I've got this is my hypotenuse. This is a leg, and this is a leg, right? So see, I'm identifying the parts. I'm thinking about it. And I don't always write it down, but I'm thinking about the parts of this triangle. What are they? So that way I can figure out what do I know and what do I need to find. And so as soon as I identify, there's already something I know what I need to do. There's one thing that's easy to do. I know this other leg, so I can go, okay, well, x equals 13 because the legs in a 45, 45, 90 triangle are equal to each other. Okay, so I already have this one. But now I'm trying to figure out the hypotenuse. So then I'm asking myself, what am I going to do? So there's two ways you can think through this. The first way, I usually just think, okay, if I'm going from a smaller side to a larger side, I'm going to multiply. So I need to multiply this times something. And what am I going to multiply it by? Well, the number that has to do with 45, 45, 90 triangles, the key number is the square root of 2. That's the relationship between the hypotenuse and a leg. The hypotenuse is square root of 2 times larger than a leg. A leg is square root of 2 times smaller. Okay, so we're going to do this this way. We're going to say, okay, well, I'm going to multiply. So I have the leg. I'm trying to find the hypotenuse. So I'm going to say, I'm going to just multiply that by the square root of 2. Now, if you're a formula person, you would have done that as well. The hypotenuse equals the leg times the square root of 2. And we're just going to leave it like this. So y equals 13 square roots of 2. And so there's y, and there is x. Okay, let's do another one here. This one, let's see what we have. We have the hypotenuse this time. Okay, so if I have the hypotenuse, okay, so I know it's a 45, 45, 90 triangle. And I have this as my hypotenuse, which means both of these are legs. And I'm go, okay, well, I have the hypotenuse. I'm trying to find a leg. The leg is square root of 2 times smaller than the hypotenuse. So I know to find this leg, it equals 30 divided by the square root of 2. Okay, if you're using a formula, you would have got that leg equals hypotenuse divided by the square root of 2. So once I have this now, I need to shift gears, and I'm going to use a different color. I'm going to use the color red to represent algebra stuff. So I shift gears out of my geometry mode into algebra mode, and I think, okay, I need to simplify this. And I have to simplify it because I have a square root in a denominator. You can't have a radical in a denominator in a problem like this, and it's not simplified when that's there. So I need to get rid of this. So I'm going to take this 30 over the square root of 2, and to get rid of this square root of 2, I'm going to multiply the numerator and the denominator by the square root of 2. This won't change my value because this is basically multiplying by the number 1. And the numerator, I end up with 30 square root of 2. The denominator, the square root of 2 times the square root of 2 is just 2. Now I can simplify a little bit further because I know that 2 and 30, those can be canceled out, and I end up with 15 square roots of 2 over 1. So I can just write that as 15 square roots of 2. And so that's what I'm going to do. So I'm going to say x equals 15 times the square root of 2. And that's also true for y. Okay. I hope that you heard those steps as I went along. Maybe you picked up on that as I was doing it. All right, let's try this next one here. Okay, so same thing, 45. That would have to be 45. 90 triangle. This is my hypotenuse. This is a leg. This is a leg. The leg is a square root of 2 times smaller than the hypotenuse. So that means I'm going to take the hypotenuse, 2 times the square root of 14, divide it by the square root of 2, and that's where we're going to go. So now there's a couple things you could do here. I could, because these are both inside of a radical, and they're both square roots, right? I could simplify based on this. So I could get 2 square root of 7 over the square root of 1, which is just square root of 1 is just 1. So 2 times the square root of 7 over 1. Usually if somebody sees a problem like this, they wouldn't write all these things down. This would be what's going on in their heads, right? They're just thinking about this. Okay, that's this, and so they go, oh, well, this is just 2 times the square root of 7. Okay, this is what x equals, and this is also what y equals, because the x and the y in this case, since they're both legs, are the same. So 2 times the square root of 7. Now, if you did get to this problem and you didn't think about canceling those out in this way, and you were thinking, well, wait a minute, Mr. Harmless, that is not how you taught us. Well, you taught us to multiply the numerator and the denominator by the square root of 2. Well, you could have done that as well. Okay? And it would have come out to be the same answer. Taken a few more steps, but it would have come out to be the same answer. Okay? So it's okay if you would have done that. You would have gotten the same answer either way. If you need to see that worked out that way, I can do that. In fact, at the end of this video, I'm going to do that just for you. So I'll come back to this one down here at the bottom, okay? But we'll come back to that later. Let's go ahead and do this last one. This last one, 45, 45, 90, 45. This is the hypotenuse down here. This is a leg. This is a leg. And so I have the hypotenuse. I'm trying to find a leg, so I know that the hypotenuse divided by the square root of 2. So I'm going to do 10, the square root of 2 divided by the square root of 2. And so this is a nice easy one here because the square root of 2's would easily cancel. That would be easily recognizable. And so you end up with 10 over 1, which is just 10. So x and y both equal 10. Okay, so that's the end of the video. If you want to keep watching, I'm going to play a little bit more here. I'm going to record a little bit more, and show you how you could have gotten this same answer. So you can stop now if you want to. If you want to watch the rest of this, that's fine. I think I can scroll down here. Okay, so extra. So 2 square roots of 14. I'm sorry, not 7 yet. 14 divided by the square root of 2. So this is for those people that said, wait a minute, Mr. Harmless, I thought you were supposed to multiply the top and the bottom by that square root. So let's do that so that you can still see that we get 2 times the square root of 7 as our final answer. Okay. So if I do that in this problem, and let's shift to red here, I would multiply by the square root of 2, square root of 2, and I would end up with this. Square root of 2 times square root of 2 is the square root of, I'm sorry, it's the square root of 4, which is just what? 2. In the numerator, I get 2 times, and these can be multiplied together, so I get 2 times the square root of 28. Now, I already see these 2's can cancel, so I'm going to end up with just the square root of 28 over 1, which is just the square root of 28. And so some go, Mr. Harmless, this is what I got. I didn't get this. Where did that come from? Okay, so let's continue here. Let's talk about this, because this can happen sometimes where you get a square root, and the number inside the square root can actually be simplified a little bit further. So let's do that. Square root of 28. This can be simplified. This can be simplified because when I look at the number 28, and I'm talking slower now because I want to make sure that you understand what's happening. When I look at this, let's see here. Right, so I'm looking at this here and put my right glasses here. So Mr. Harmless, when he looks at this, he's looking at this and he sees in his head, he goes, "Wait a minute, I recognize this. This is divisible by a perfect square." Right? That's what happens when I see this. Okay. And I think to myself, well, that's divisible by a perfect square. So I know that I can simplify this a little bit further. Okay. I know that I can simplify it. That's a horrible chin. I know I can simplify it because I know that the perfect square is divisible by is the number 4. So when I see this number, I automatically go, man, this number can be broken down this way. And this might look like a factor tree to some of you. 4 times 7, right? Now I split it up this way because this number is a perfect square. It's a special number. I can actually do the square root of 4. The square root of 4 comes out exactly as the number 2. The square root of 7 does not come out exactly as anything. It's a never-ending, never-repeating decimal, so I'm going to leave it as the square root of 7. So the square root of 28 simplified is 2 times the square root of 7, which is exactly what we had up here. Now, I know that this seems like a longer way to do the problem compared to the first way that we did it. But it's okay to do it this way because it's important to understand that sometimes you're going to get this regardless. Even if you could have done something else before, sometimes you're going to end up with a number that could be simplified that's just inside a square root. And it's simplifiable because it can be divided by a number that is a perfect square. Okay. If you need more help with that, feel free to ask. Submit questions to me. I love making little videos and I'll be happy. See, there's my little smiley. I'll be happy to do that for you. Okay. I won't be angry. Okay. Thanks for watching. Hope this was helpful.